Smiley faces, smiley faces. Okay, now it's working. Now it's working. Alright. Okay, so this is a late stream. I normally don't stream on this time. I'm gonna try to focus on English. I'm gonna try to make this whole stream in English. Let me create a task here. So we are going to start with Neso Academy pointer. Let me see pointers, exercises. All right, and then we also actually we are probably going to, I don't know, maybe it says 50 later. So let me create smiley faces, smiley faces. All right.
In this presentation,
Laggy. So this is lecture number 127. It doesn't seem I don't have this folder. I have 126. Okay, so I have stopped it here. Let's watch it. Let's watch it, shall we? Let me just see if everything's correct. Yeah. Okay.
we will deal with another question related to pointers. So let's get started. A C program is given below. Here is a program available in front of you. What should be the contents of the array B at the end of the program? We need to identify the contents of this array B at the end of this program. Obviously, one of these options is the correct option. So you need to
What should be the contents of the array B at the end of the program? Let's see. Alright, so we have two variables, I and j, we have two arrays. This is a matrix two-dimensional array. Two-dimensional array. We have another one at the end. Okay. Okay. I'm gonna take a screenshot here. And then I'm gonna paste it here. And then okay, so the pointer P is being assigned this. B is a two-dimensional array. If it was only B, it would be the address of the first character of the first one-dimensional array. But this, I don't know what this is going to give us actually. I'm not quite sure. Okay, so we have two nested for loops. The outer one is going to run 2 times or twice because it's 0 and less, and the inner is going to run 3 times. And then we have some pointer arithmetic here. So I'm actually not quite sure. $187. I'm going to write it down on Nailvim, and then I'm not gonna run it, but I'm gonna just write it. So this is number 9, right? Number 9. Yeah, number 9. So this is going to be 127. Oops. The question is, what should be the content of the array be at the end of the program? Alright. Let's delete those functions. And let's J, and then we have a matrix A 2 by 3. It's going to be a matrix of characters. So A, B, C, and then D, E, F. There we go. I'm going to actually break a line here and here as well. So we have this. I don't know. Alright. And then we have another matrix of characters. This one is B, and it's 3 by 2. And we are actually not going to initialize it just yet. And then we have the pointer, it's called P, which points to star B. So I'm not quite sure what presents here. And then we have two nested for loops. So we initialize I, which is declared on this line, and then -2, less than 2, I++, and then the inner loop. And then we have some pointer arithmetic, P, plus 2 times, what is it? Is this just normal multiplication? 2 times j, like this, plus I equals interesting. He got some white space here, here, and here. I don't know why. I don't know if this is going to interfere with the program's execution. I guess no. Okay. So what is this right here? Is this a pointer to the whole 2D array? Let's do some testing here. So I have a C file. Let me actually delete everything here. Let's say I have a matrix, okay? So this is going to be int matrix 2 by 2. Like, I don't know, something like this. 10, 20, and then 13, 14, right? So if I have a pointer, ptr, and I do this, is this pointing to the whole, to the array? So that's my question, right? So let's say I want to print ptr plus 3, ptr plus 3, is it plus 3? Plus 3. This would be 13, right? Or let me see. Actually, before doing that, let's print the content of of this pointer. So the content of pointer is some address, and then let's do ptr equal to matrix, and then let's print again. Let's print again, and this could be the same memory address. So let's see, index, get an error. Okay, line 12 here. I see. Because the type of the pointer is actually different. Right here, the type is int, like this, right? Well, I don't know much about this, but I guess it's. And then here the type is actually just this, so it doesn't work. So let's do a second pointer and initialize it to just matrix like this. I guess it points to the first 1D array. And then here we are going to print the content of pointer 2. And let's try to execute it. Let's try to compile it, and again we have an error. Because this gotta be like this, I guess. Let's see. Nope. This one. What? So this is wrong. Invalid initializer. What? And then well, I don't know. I don't know. I don't know. Okay. That's okay. So what is this? What is this right here, boys? What is P? Let me search. Okay. So it decays to a pointer of 4 integers, right? Or something like that. Of the size of the columns. Is the stream? So what? Okay, let me see. Let's see if this compiles. Okay. And then we have some memory address. What if I do this right here? What is going to be the this gotta be a decimal. Okay, 40 because we have 10, 12, 20, 13, 14, and then it was pointing here, and then plus 3 is going to point to 40. Alright. Alright. What if I do this? Can I do this? No. I don't know why. Do I have to do this? Like this? No. It says invalid initializer. Invalid initializer. Invalid initializer. So I actually don't know what this represents. This star B. If it's the address of the whole to the array, or if it's the address of something else. Let me watch a little bit of the class, of the lecture.
To identify the correct option, I would encourage you to pause the video for a while and try to answer this question on your own.
I just gotta know what exactly it's pointing to.
It says that declare a character array A, we have to declare an array B also, which contains 3 rows and 2 columns. Okay, here in this case it contains 3 rows and 2 columns. Now with this statement we are trying to declare a pointer P, which is a pointer to a character, and we are assigning it star B. We know that B is pointer to the first one-dimensional array, right? So star B will give the pointer to the first element of the one-dimensional array. So star B is giving us the pointer to the first element, that is this element of the one-dimensional array. So we are basically
Okay. 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 I got it. So in the example here, why can I not do this? Like this. Anyways, okay, I got it. Okay, so let's try to solve it now. Let's try to solve it. Shall we? What the hell is this? Okay. 2 times j. J is going to be 0 at the first iteration. Plus I. I is also going to be 0 in the first iteration. But what is P? P is okay. P is the pointer, the address. So we are doing some pointer arithmetic, and then dereference it. So this is the actual value, the actual character. Got it. And then we are assigning it whatever this is. So let's do it step by step. Let's do the first iteration. So first iteration is going to be P P plus 2 times J, which is 0, right? Which is 0, and then plus 0, it's basically not going to, it's going to be plus 0 is equal to I and J, alright? Which basically means that the first character, which is A, is going to be assigned with A. So nothing's going to effectively change. So equal A. So the second iteration is going to be something like this: P plus 2 times 1, which is going to be 2, plus I, which in this case is still 0, is equal to a 0, 1. So the the third element, this basically means that B 0, 0 equals to this, and then here what is this element? This element is it's row 1 and first column, right? Yeah, I think that's correct. So it's going to be the second row in the first column. It's going to be the element 0, 1. So B. right? And then we have the third iteration, which is going to be 2 times j. J is wait, yeah, j is 2, so 2 times 2 is going to be 4 plus 0, so this is going to be 0 to be at the position. Okay, this one is going to be a little bit tricky to find this position of B. What is the position of B here? It's going to be pointer plus 4, so we are here, plus 4. Let me draw an arrow here. So it's gonna be here, 1, 2, 3, 4. But okay, but this is different. This is 3 by 2, so let me actually write it. So we have 1, 2, 3, and then 4, 5, 6, 7, 8, 9. So this initially is pointing to the first one. Let me draw an arrow, a red arrow. So it's pointing to here initially, and then we do plus 4, 1, 2, 3, 4. So it's going to point to this second row, which is 1, index 1, and column 1 as well is going to be equal to whatever this A is. So 0, so it's C, right? It's going to be C. Alright, and then P is going to be 3, which is not less than 3. It's actually equal 3, so it's going to run the outer loop. So I is going to increment. We're going to increment I. Do we have a pattern? A pattern? That's the question here. Because if we do have a pattern, I can just reuse, so I don't have to do it manually again. I think. What is a pattern? I don't know if we have a pattern. Anyways, let's do it again. So we're going to have P plus. Okay, so just to remember, this time I is equal to 1. Oh no. Okay, yeah. This time I is equal to 1, and then we have P plus 2 times j. So it's going to be the exact same here. The exact same. All right. Yeah, it's going to be the exact same, but no, it's not. no, it's not gonna be the same because we have plus I, so it's gonna be 2 times j, which is gonna be 0 plus 1, and then we have we have p plus 2 times j. J is going to be 1, 1, so 2 plus 1, and then finally we have to multiply 2 by 2, so it's gonna be 4 plus 1. Yeah. So the only difference is that we are adding 1. So now this is 1, 3, and 5. So we have 0, 2, 4, 1, 3, 5. So this is the odds, okay? We have the odds. And then, oh shit. Wait. Okay, so it's always gonna be 1 here, and then here it's going to be 0, 1, and 2. Alright? 0, 1, 2. Yeah. 0, 1, 2. Okay. We just have to find out the position of B. So B is going to be okay, so P plus 1 is going to be this guy. This guy. Right? 1, 2, 3. It's gonna be 1, 0. What? P plus 3. 1, 2, 3. P plus 2. 1, 1, 2. Okay, this is wrong. So it's 0, 2. It's 0, 2, and then 1, 2, 3, 4. Yeah, this one is correct. And then plus 3 again. 1, 2, 3. It's gonna be 1, 0. So this is correct. And then we have 5 plus 5. So 1, 2, 3, 5. So this is also correct. But the letters, the characters, they're going to change. So this is not going to be A anymore. This is going to be D, I believe. This is going to be E, and this is going to be F. Yeah, this is F, right? And then we don't print anything, but he's not asking what is going to be printed. He's asking what should be the contents. So there is no pitfalls there. Let's see, we have 4 options: A, B, C, and D. And we have A, B, C, D, E, F. Okay, So what is going to be printed is going to be B00, which is A, B01, which is D, B10, which is E, B11, which is F. Wait a second. We don't have B20. We never... What? What? Okay, so this is wrong. This is completely wrong. I think. Okay, so we have AD. Let me see if we have... Okay, AD, EF. No, this is not EF. Okay, this is... Okay, that was wrong. That was completely wrong. Let me drink a little bit of coffee. It's okay. It's okay. I just gotta review everything. Alright? I just gotta review everything. Alright, so let's see here. I have 2 times 0. It's gonna be 0 plus I0, so it's plus 0, so this is correct. This is correct. And then it's going to be equal to... This is also correct. So I think the first character is actually A. Right? It's actually A. So this is correct. So we have A. Okay, so all the options have A. Just to make things more difficult. Okay, so this is correct. This first line is correct. Well, let's see the second line. In the second line, we have 2 times J, which is going to be 1. So we have essentially 2 plus 0. So this is also correct right here. And then we have 0, 1. This is also correct. And then, let me see. Plus 2 is going to point to 0, 0, 2. 0, 2, which is this guy right here, right? 0. Let me see. Wait. No, it's actually... Yeah. 0, 1, 2. 1, 2, yeah. So it's 0 and 2. This is also correct. What? So we should have B in the second. So it gotta be A here, no? It gotta be option A here. There is no way it's not option A. I mean, obviously there is a way, but let's see this element here. So we have we are going to have P actually 2 plus 2 times j. J is going to be 2. And then we have 4 plus 0, which is 4. So this is correct. And then this is also correct. Plus 4. So let's see. 1, 2, 3, 4. It's 1, 1, 1. Right? And it's C. It's C. So C is going to be the second row, second element. Oh, there is no way. Okay, let me run this. Let me run. We get a print. 4. We get a print each element, so we're gonna do something like this. Actually 3. Something like this. B, J, and then let's actually put char. Actually, it's put char. C. Okay. Yeah, so that was wrong. That was wrong. We have actually AD. How is this AD, bro? Huh? How is this AD? AD. Oh. Oh, this was wrong. This is 3 by 3, bro. 3 by 3. But the thing is actually 3 by 2. E aí, Paulo? Tá aprendendo qual linguagem? Tem bastante matemática. No começo você vai ter matemática discreta, né? Eu acho, em todos os cursos, né? E talvez cálculo também, não sei como é que é. Eu tô fazendo um stream em inglês, tá? Porque, sei lá. Porque eu quero treinar o inglês, eu acho. Eu tava enferrujado. E também porque eu faço streams na Twitch, né? E lá tem um público mais internacional. Espero que não incomodem vocês. Também essa stream aqui, ela tá no tempo em um horário errado, né? Errado não, diferente, né? So anyways, the drawing was actually wrong. This is the representation of a 3x3 array. But we actually have a 3x2 array, so we should have 2 elements and not 3 elements. So this is going to be 3, 4, and 5, and finally 6. Okay, so let's redo it. So the first element is actually A, but the second one is +2. Okay, this is... Oh, okay. Okay, I got it. Yeah. I got it. Yeah. Exercise number 9. Pointers. Git push.
Basically trying to assign the address 4000 to this pointer P. Obviously it is a pointer to a character, that's why it has to point to some character. It should not point to the whole array, it should point to some character. So here is the pictorial representation of a pointer P, which is pointing to the first element or the first location of this array P, right? After this we will evaluate these two for loops, and within these for loops we can see that we are initializing the variables I and j with 0, right? So these are variables I and j and they are initialized with value 0. Within this for loop we have to evaluate the statement which says star p plus 2 into j plus I is equal to a00. A00 means the first element of the
A00,
which is actually a character, that is character A. So we can replace this by character A, right? Let me now evaluate this statement, star p plus 2 into j plus I. We just have to replace p, j and I here, right? P is the pointer to the first element of the character array B, which is containing the address 4000. So let me replace this by 4000. And j and I can be replaced by 0. 2 into 0 is 0. And 0 plus 0 is again 0. So 4000 plus 0 will give 4000, right? And what does this statement say? Star 4000 equals to A. It says that go to this location and store character A within that. That's it. So after this statement, we'll increment the value of j. J now becomes 1. 1 is less than 3. Of course, condition is satisfied. We'll come inside once again. I and j again get replaced by 0 and 1 respectively. So we'll replace them by 0 and 1. And it gives the second element of this array A, which is basically a character B. So let me replace this by character B. After that, P is the pointer to the first element. It is already there. P is the pointer to the first element. So we can replace this by address 4000. And of course, this can be replaced by 1 and this by 0, because this represents j and this represents I. 2 into 1 is 2 and this is already 0. So 4000 plus 2 is 4002. That is this particular location. We will store character B within this location, right? After this again, we will increment the value of j. J now becomes 2. 2 is less than 3, condition satisfied. Come inside once again and we need to evaluate the statement once. This time,
we got it.
Which is this character, right? So let me replace this by character C.
We got it.
P will get replaced by 4000 and j by 2 and I by 0. 4000 plus 2 into 2 is 4004, right? And here is this address 4004. So let me store character C within this location. After this again increment by 1.
Angela, we already... Yeah. It's always the details, man. It's always details. Let me do this so people know.
Microphone muted. Microphone activated.
Is this actually a bot? There is no way. I think we finished the pointers exercises. That's a tough word to pronounce. We have a basic of string literals, string. I mean, it's also about pointers, but it's not in the title. Tougher topic, simple solution. Thank you to take me deeper when I was just a noob a week before. An incredible playlist on Pointer. What? Okay. Let's start again. Press spacebar. Okay.
From this.
Alright, so we have a class number 128. Basic of strings literals.
This presentation onwards, we will start with a new chapter called Strings, and in this presentation we will consider some basics of string literals.
Okay, so we are done with pointers.
So let's get started. Here is a definition of a string literal. String literal or string constant is a sequence of characters enclosed within double quotes. For example,
new topic. Let me go into take notes. here.
Example, I can write something like this, that is hello everyone, and this is a string literal because it is enclosed within double quotes. Also, it is a sequence of characters, right? In Spanish, I can say hello everyone as hola a todos. This is also a string literal. Apart from this, in German,
How do you
as hola a todos.
Hola a todos.
This is also a string literal. Apart from
Hola a
this,
todos.
I can say hello everyone as hello zusammen, and in Italian it is ciao tutti.
Ciao tutti.
These are all string literals because they are sequence of characters enclosed within double quotes, right?
And in Portuguese you say hola a todos.
Apart from this, percentile s is a placeholder which is used in place of a string literal. That is, within printf function, I can use percentile s.
Okay, so let me search. So when using with percentage s, basically keeps doing pointer arithmetic until it finds a new character. Okay, when the person has a more specifier, the corresponding argument is expected to be a pointer to the first character of a new terminated string printf, then iterates through the memory locations. This process effectively involves pointer arithmetic, as printf internally increments the pointer to access successive characters in memory. The no character serves as a sentinel value. Okay, so it's like a stop. So keep incrementing, doing pointer arithmetic, but once you find the no character, stop, indicating the end of the string. I get it. Ooh. Interesting stuff right here. So if I'm not mistaken, printf actually returns an integer. I don't know exactly what it is. I think it's the number of characters successfully printed on the screen. So if you do nvim index.c, I don't know if you guys are able to see this. Anyways, so let's do string. So let's do const char string str, something like this. Hello has 5 characters, actually 6 characters if we count the no character at the end. Alright, this is wrong because it's here. Okay. A non-constant pointer points to a constant array of characters string. I don't know if you guys can see. There we go. it's constant because it behaves, or it should behave like a string literal. And then if you use n equal printf, something like this, and then str, and then n. The characters successfully printed. So it should have hello and oops. Wait a second. And then 6 characters successfully printed. This is what I expect. Let's see. So if we compile it and run it, alright. Okay. We have hello and 6 characters successfully printed. Really nice. Really nice.
As a placeholder for this particular string literal. Apart from this, there is one important point I would like to mention. String literal is always enclosed within double quotes. It is not the case that you can enclose a string literal within single quotes. Single quotes are used to enclose a particular character at a time, while double quotes are used to enclose a string literal. So this one is correct, but this one is not. Also, I cannot write something like this in C program. Suppose I have a string literal, which is a big sentence, that is, you have to dream
sentence
dreams can come true. What I want in my program is to mention this sentence in the next line instead of mentioning this in the same line. But this is not allowed in C programming. This particular printf function will produce an error message. You can add a backslash at the end of this sentence, and this will allow you to mention this sentence in the next line. Because of this backslash, there is no error produced by this particular printf function, and hence it is totally legal in C programming. Let me tell you that this method is called splicing in C.
I actually do this, but in Bash. We have something similar in Bash scripting. So for example, let's say I want to echo something like really big. I can do this. I can do like hello and then backslash enter world. Actually, I think the exclamation mark fucked me. Okay. See? So we have something similar in Bash. If you want to write a very long command, you can do like a backslash and then the other stuff on the second line. You know, we actually have a printf in Bash as well. Wait. Okay, it doesn't work. Maybe with the E flag? No, it doesn't work. Never mind. Shit.
C language. But I have to mention that there is one disadvantage of this slash.
What?
And let me mention this disadvantage through a live running program. I have already discussed about this backslash method. With this backslash, I would be able to mention this sentence in the next line. This is alright, but there is another method which will allow you to mention this sentence in the next line.
Abdul?
Each and every sentence should be mentioned within double quotes. This first sentence should be mentioned within one set of double quotes, and this next sentence should be mentioned within another set of double quotes. This will also allow you to enter the sentence in the next line, and of course it will improve readability. As I already told you that there is a disadvantage of using this method. Let me show you by running this program. We can see here that in the
Okay, so it actually adds some white space here. Interesting. Why would it do that? I have no idea. Is it escaping a new line or something? Is it escaping a tab character? There is no way, it's enclosed in quotes.
the first sentence, there are additional spaces added which I don't want to add, right? Why these spaces are added in the first
That's what I'm asking.
sentence, while in the next sentence there is no such problem. We can see here that because of this backslash, these spaces are also included. It considers
Oh. So these spaces right here. That's crazy.
these spaces as part of the sentence. This is basically an indentation, a one tab, which is equivalent to 4 spaces. But these spaces are also included.
I mean, it depends on the editor.
Because of this backslash. But as we can see, this is not a problem with this printf function. Because of these double quotes, this indentation is not considered at all.
Okay, let me take some notes here. I actually have something. Let's take some notes. I'm gonna create a file, name it 128.med. It's going to be a markdown file. Nisso Academy. The name is basic offstring literals minerals. And what is important? What is important?
This function.
Okay, so strings in C. Let's do like this. Strings in C. Oops. Strings in C are, in fact, pointers. Actually, strings in C are in fact pointers to the first character. So a string is essentially an array of individual a new terminated array of individual characters, right? So if you do like this, let's see, char, actually like this, and then we have like hello, this is equivalent to to the following. So we have something similar, however, this one is, we can do like just hello, so it automatically adds the new character. At the end, I think, it gotta be it. Which is also the equivalent of the following. Oops. So this we can turn this into a pointer. Oops. Like this. Alright. Is this correct? I guess. And then what else do I need to? Oh, okay. So printf is going to return an integer, which is the number of successfully printed characters, including the no character. And also, we have here okay, so printf iterates, yeah. Okay. So let's have another code example. I'm going to just copy this code is snippets. And printing very long strings. We have two options. So we can how is this? So we can oops. This is a very long string, believe me. this is the second part of the very long string literal. So this is the first option, and then we have the second option. Basically, let me see. Yeah, so basically you're going to remove the backslash and add like this. So we can say the second option is preferred. Is that how we pronounce? Preferred. 2 R's. Sim. Educação sempre vale a pena, né? Claro que existe uma questão também de otimização. Eu vejo que as pessoas no Brasil são muito focadas em faculdades que muitas vezes são longas, 4 ou 5 anos, quando de repente poderia fazer algo mais curto, como um tecnólogo, por exemplo, que vai durar entre 2 e 3 anos e que de repente te coloca mais rápido no mercado de trabalho. Até porque experiência profissional vale muito mais do que a faculdade, né? Inclusive, tecnólogos são muito comuns em países como a Alemanha, por exemplo, né? Então, desculpa eu estar fazendo stream em inglês, né? Eu falei isso, mas é porque, sei lá, eu quero fazer em inglês essa stream. Eu fiquei com vontade de fazer um stream 100% em inglês. Quer dizer, 90% agora, né, que eu tô falando em português. Anyways, let's actually try to let's do this. I'm going to copy this, paste it here, and then let's see what is the output. Okay, let me add some space. I need some space. Which are you like? Okay. Okay. So both prints correctly, but the first one actually adds a little bit of white space here. So we are going to say, because unlike the first one, it doesn't add the extra white spaces. How long have you been studying programming? I studied programming for since 2019, I think, but it's not. I wasn't like consistently studying, you know. There were a lot of times that I stopped it. I don't know why. In 2020, my mind just, you know. I think I just forgot everything. I was not thinking straight. But now I'm coming back to the studies. You can see on my GitHub that I am way more consistent now. Hello, Lua Maria. That's a very Brazilian name. Okay. What else? What else? I think that's it for this lecture. That's it for this lecture. Let's go to the next one. Number 129.
In addition, we will learn how string literals are stored in memory. So let's get started.
Yeah.
Here is a printf function, and within this printf function, I'm basically passing a string literal earth, right? So earth is a string literal, and first argument to the printf and scanf function is always a string literal. Printf and scanf function always asks for a string literal as in first argument, right? But what we are actually passing to the printf or scanf function? That's the...
We are passing an array of individual characters and a new terminated character at the end of this array, right?
Question of concern. You might be thinking that we are passing the string literal, but in reality, we are passing something else. For this purpose, we have to understand how string literals are stored in memory. String literals are stored...
Brazilian living in Stockholm and starting to study programming. Whoa, that's really nice. Stockholm, Sweden, right? Yeah. Ish. Programming is really nice. You know, it's like a mental training. You know. Cara virou gringo. It's a string for all. Inclusive string. Are you doing some kind of college degree right now? No. Yeah. It's ADES. Uninter. I gotta practice my English, Julio. You know, I was getting rusty.
as an array of characters. There are no exceptions. String literals are stored as array of characters. We have these characters, like in this case, in our example, we have an earth string. So this string literal is stored as an array of characters, and it is always ended by the /0, that is a null character, which indicates the end of the string. It is automatically...
I started with Python, yeah. A lot of people start with Python. It's a high-level language. It's kind of nice. Python, I believe you can do a lot of things quickly with Python, so you can see quickly the output. You know, you can see things getting created on your screen. It's the same with JavaScript, because with JavaScript you can manipulate elements on the screen on your browser, for example. Yeah. But yeah, C is very good to start with, because it gives you a lot of fundamentals of what's actually happening, you know, under the hood. But it's not very visual, you know. A lot of the times, everything you're gonna see is just a terminal window, you know, black, white text on a black screen, and not much more than this. But also later you can study a graphical API, and you can start building, you know, visual stuff using C. Yeah. Yeah.
Added by the compiler. Okay. Now to this string literal, total 6 bytes of read-only memory is allocated. This whole string literal has been allocated total 6 bytes of read-only memory. It is a usual
6 byte, huh?
assumption that a character will take 1 byte of memory location, and here we have total 6 characters, hence total 6 bytes of read-only memory is allocated to it. And it should also be noted down that \0 character must not be confused with a 0 character. Both are different.
Yeah, but what if I do like I was gonna do something. What was it? Yeah. For instance, I can like let me do this right here. Look. Name equal t-pose, right? So we have 5 characters, actually 6 characters, and then I can do this, and that's fine, right? Why is it? Because, okay, let me... Actually, it's not fine. What? I remember doing that. I remember doing this. It was fine. What? 0, 1, 2, 3, 4, 5. Oh, you gotta be an array? Oh yeah. I think I read this on this article right here. So this article basically says that you should not be using scanf to receive input, and there is an example here where he here can you see he did a equals 0 and not the null character. No, actually this is not what I'm talking about. He's just replacing the new line character with 0. Yeah. Okay, so you're telling me that if I do this, for instance, I'm gonna have an array that is going to look like this. Right? Actually, right? This is not so how am I doing? Yeah, I think this is it. That's the index too. Yeah. So basically, I think that's what happens. So it's going to basically print it's going to print TP, right? Oh no, it's actually wrong. Wait, 0, 1, 2. Oh yeah, it's wrong actually. Yeah, 0, 1, 2, 3. I'm gonna replace for 2. Yeah, we have TP. We have TP Inc. Trevor Phillips Incorporations. There we go. Trevor Phillips Incorporations from GTA 5. I love that mission. Okay, what the hell am I doing? Okay, so basically, when can I do this with a pointer like this? Can I do this? This is the same as doing. Wait. This is the same as. Can I do this? I guess. No. Interesting. So I can do it with an array, but I cannot do it with a pointer. Why is that?
\0 have an ASCII code as 0, while that of a 0 character has the code 48. So they are both different, they must not be confused with each other. Okay, it is fine, but what we are actually passing to the printf or scanf function? As I have already told you that we are not passing the whole string literally.
Array sobre essa da. And the other is a pointer. Oh, wait. Okay, so I can do is pointer arithmetic. So I can do aim plus 2 equals 0, and that should work the same. No. What? I also don't remember why. Yeah, that's the mystery. Okay, let's compile it with a special flag, which is going to compile it with a specific C version, which is C11. But yeah, no, it's actually like this, right? Yeah, it still doesn't work. That's weird. It should be working. Name is a pointer to char, So it points to the string literal of the pause. Oh, it's read-only memory. So this is read-only memory. Okay.
To a printf function or a scanf function, we are actually passing something else. Now what is that?
We are passing the address of the first character, right?
In C, compiler treats a string literal as a pointer to the first character. After storing a string literal, compiler will return a pointer to the first character.
Let me see if everything's working fine. Yeah.
Hence, compiler treats a whole string literal as a pointer to the first character. So to the printf or scanf function, we are passing a pointer to the first character of a string literal, and we are not passing the whole string literal. It should be noted down that in reality we are passing pointer to the first character of a string literal. Okay? Both printf and scanf functions expects a character pointer char star as an argument. They are always expecting a character pointer as an argument, and if I'm talking about...
Okay, so both printf and scanf functions expects a character pointer. Okay, makes sense.
This printf function and I'm passing a string literal to it, actually it is equivalent to passing the pointer to the letter E. Automatically printf function will traverse the whole...
So I already kinda knew this, so this is nothing new.
String. And when it reaches the \0, then it identifies the end of the string is reached, and hence the whole string is traversed. So if we are passing a string literal to a printf function, actually we are passing the pointer to the first character of the string literal. In this case, we are passing the string literal earth, which is equivalent to passing the pointer to the letter E. Okay friends, this is it for now. Thank you for watching this presentation.
Wait a second. I think the clock just... Oh no. Okay. Yeah, I gotta disable that extension later. It's frozen the tabs. Okay, so what is the takeaway from this lecture? The takeaway is that... Yeah, the takeaway basically is nothing new. So I'm actually not going to take any notes on this class, on this lecture. I actually don't know the difference between class and lecture. I think class is more like the group of people, and lecture is this right here. Not quite sure.
In this presentation, we will learn how to perform operations on string literals. So let's get started. Let's say we have a string literal hello world and
performing operations on string literals.
Recall that writing string literal is equivalent to writing the pointer to the first character of the string literal. So if you're writing a string literal, compiler will treat it as a pointer to the first character of the string. As when it is allocated some memory, then the pointer to the first character is returned. So, writing a string literal is equivalent to writing the pointer to the first character of the string literal. That means you have the address of the first character, right? If we store it somewhere, that is in some pointer, then we can use it for further reference. So, we can store it within some pointer ptr, and that pointer must be a pointer to some character, right? So, ptr...
Usually lectures are passive and classes are more interactive. Gotcha, okay.
Contains the address of the first character of the string literal. Apart from this, as writing hello is equivalent to writing the pointer to the first character, therefore we can subscript it to get some character of the string literal. See this string literal over here. If we write hello over here, then it is
You are missing a semicolon right here. This is going to not compile.
Equivalent to writing the pointer to the first character, that is pointer to h. Therefore we can subscript it to get some character of the string literal. For example,
When you do name truly. Oh, okay. So that's basically what Samuel said here. He said store it in read-only memory. Yeah. That's what she said. Yeah. Interesting. That's nice to know.
hello1 is equivalent to pointer to h1. We can subscript this hello string and we can access this character, that is second character of the string. How we can access it? We know that hello is stored as a...
What is he doing? Is equivalent to writing the pointer to the first character. Therefore, we can subscript to get some character. Okay. But, okay, so we cannot write it like this, but we surely can read it, right? Surely we can read it like this. So this is going to give me this is gonna be O. Yeah. There we go. And what if I pass, instead of this format specifier, this one? Oh, it's gonna give me an error. Yeah. So the format specifier doesn't match the type of the argument. Yeah. Very cool. Interesting stuff.
Sequence of characters, and that too within an array in a memory, right? 1000 is the starting address.
I gotta learn about the different memory locations. I keep hearing about heap memory and stack memory, but I think I'm gonna study about it very soon. But until now, I actually don't know much about it. It's wrong. No, I think it's correct, no?
Of this array,
Because he's saying like 1 here.
that is the address of the first character. Similarly,
Entendendo algoritmos. Okay. Let me see this book. I just read English books. Okay. Oh, I know this one. I actually know this one. Yeah. Maybe. Yeah. Very good reading to understand this kind of stuff. Very beginner friendly. Yeah. Yeah, it's going to print E.
1001 is the address of the second character, and this address has been obtained after assuming the size of character is 1 byte long. I want to access this character using this subscript. How we can access it? Pointer to h1 is equal to star pointer to h plus 1. And what is pointer to h? Pointer to h gives us the address 1000. Pointer to h is equivalent to the address of the first character, therefore it can be replaced by the address 1000. And 1000 plus 1 is 1001. And after dereference, we'll get this character E. So pointer to h1 is equal to hello 1 gives us the character E. Similarly, hello 0 gives the first character, hello 2 gives the third character, hello 3 gives the fourth character. And
yeah, you gotta use the imagination here, right? Or can you actually write it this way in C? Is this proper syntax? Or is this imagination exercise? Yeah. Can I do what he did? Like something like this? Can I do this? Printf. And then I want to print string literal, passing, suppose programmer, but let's say I want to just a second, so 1. If this works, it should be P, right? Let me try to compile it. This is going to work? Yeah, it works. Interesting. So it's actually proper syntax. Hold on a second. What the hell is this? So S, is this going to work? I think it gave me a warning, but it actually compiles, right? No. Well, it compiles, but
and so on. Now, there is one point to be noted down. String literal cannot be modified. It causes undefined behavior. If
okay.
we try to modify,
So even if I don't do, like, put the const keyword here, I still cannot modify it. Crazy. So that's why functions, they expect, like they expect const char pointer string. That's the reason why. Like this. Yeah, that's kind of cool. That's pretty cool. Wow. Okay.
modify a string literal, then it definitely causes undefined behavior. Suppose we have a program in which something like this is written: cast rptr.
Got it.
equals to hello. We are trying to store the address of the first character within this pointer ptr, and with the help of this pointer we are trying to modify this first character and we are trying to change it to the character m, but we won't be able to do this. This is not allowed. Why? String literals are also known as string constants. They have been allocated a read-only memory, so we cannot alter them. It is
I have to take notes on this. This is important.
It is not possible to alter any of the characters of the string literals because they have been allocated a read-only memory. So we cannot alter them. So it is clear from this fact that we can obviously access each and every character of a string literal, but we won't be able to change any of its characters. Also, character pointer itself has been allocated read-write memory. This has to be noted down that this PTR pointer has been allocated read-write memory. We already know that this string literal has been allocated read-only memory, but this...
So we can change whether the pointer is pointing to. Got it.
It's not the case that this also has been allocated a read-only memory. PTR is the pointer which can point to some other string literal also. So it has been allocated a read-write memory. Okay friends.
Okay, really cool lecture. Let's create a 113.med and then let's take some notes. What is important? Okay. Have you already studied stacks and no. I mean, I know I studied what is it called? The stack before studying recursion. I had to study a little bit of the cycle, you know. It's you know, it's like stack. It's called stack. Like F first in, last out. Yeah, first in, last out. Something like this. Something like that. Okay, so writing is writing string literal is equivalent to writing the pointer to the first character of the string literal. So when you do, let's see an example here, sharp ptr, so this is hello, ptr contains the address of the first character of the string literal. What else? We have this. Yes. So this is important. String literal cannot be modified, causes undefined behavior. Why? Because it's stored in a read-only memory location. So even if we omit the char name pose +2 equals 0, undefined behavior. Undefined behavior. And then what else? Yeah. Okay. String literals, also known as string constants. So we cannot alter them. Alter. Unless how is it? Like this? Like this? And then we cannot modify where the pointer points to. That's it. Do we have anything else to... Yes, for now, web development is my main focus. Even though I don't stream web development, maybe I should. Yeah, I can even show you what I did. Like, let me show you before finishing this stream. So I did like an agenda project using Express. Let me see if I can find. But I'm also studying. I also tried to not use Express to build like a routing system just with the Node.js built-in HTTP method module. So let me see if I can find Express yourself and the mini project, and then we can maybe cat package.json. Yeah, npm start to start the server, and we can do localhost 5000. So this is the wait, let me actually show you Express yourself. See the mini projects. Okay, so so as you can see, I'm not using Express. I'm just using the HTTP core module of Node.js itself. And I actually created some helper functions here. That basically helps me writing better code, because this can grow really quickly, you know. So I'm using like early return statements and a bunch of stuff. So if I click here, I'm gonna change the route to about. There we go. We are in about page. And if I put any other route, that doesn't exist. We have this one right here. Basically, it's going to render a 504. I mean 404. How to say this? 404 page. Yeah. So page not found. We can return to the home page. Basically, since I'm using return, it only is going to reach this part of the code if the route doesn't exist. But I also did an agenda project. Let me see if I can find it. Section 11. Let me see, section 11. npm start. Yeah, so we have this one is bigger. So this one I'm actually rendering HTML files by using the FS file system core Node.js module. But this one I did following a Udemy course. So I had a lot of help on this one, and we are actually rendering server-side templates, EJS, which is embedded JavaScript. So you can see the server right here, it's way bigger, and if we go into port 3000 here, this is the project. So basically, if I click on edit, I'm not logged in. It's not let me edit. So I actually need to sign in. There we go. Yes, it is. Okay. Sign it in. So I can edit. So this is the 4th. See? 4th. And a bunch of stuff like this. Yeah, it's using MongoDB. You can see it right here. MongoDB connected and a bunch of stuff. But I need to study MongoDB, to create a project without following a tutorial, like create a project by myself, I'm using Mongoose to interact with MongoDB on this one. And I can obviously log out and a bunch of stuff like this. But yeah, that's it. I'm going to finish the stream. Also, I wanna tell you guys this. So I'm planning to create YouTube videos, and they are going to be in English. Okay, I'm not going to make them in Portuguese. The videos are going to be fully in English. I'm gonna, just talk about stuff that are like Linux, stuff like this. I'm gonna talk about how I created this right here. Basically, this is a bash file to take screenshots, so I'm going to create a video talking about this, how to create this step by step. I think it's gonna be really cool. So that's it. I'm going to end right here. Thank you for your presence, everyone, and and I see you tomorrow. Hopefully speaking Portuguese and in daytime, because I normally don't stream this time. Tamo junto, Júlio, tamo junto, Samuel, tamo junto todo mundo que colou. Lua Maria. E cara, I think it's broken it's broken my followers and stuff, like the alerts. But yeah, that's it.